Hey, what is going on everyone? I'm Wicked and today I'm going to dive even deeper into the concept of build context, talking about how it works inside Flutter and therefore how it is used by the Bloc library to provide different blocks or qubits across the widget tree. This is a really important tutorial, so make sure you don't skip it. We will be going to tackle up different scenarios to see how build context can cause the unwanted BlocProvider.of fails to find a context containing a specific block or qubit error. So, if you encounter this issue too often, it's a great idea to watch this tutorial in depth. So without further ado, let's get started. Beforehand though, you can check out the content overview for today's video and its specific timestamps. Remember from my third tutorial of this series regarding Flutter block concepts when I told you that everything in Flutter is mainly a widget and that Flutter uses what's called a widget tree in order to organize and structure the widgets you want to set up and use inside your application. But how is this widget tree structured at the end? What links everything into place in a perfect harmony? You guessed it, the build context. So, the build context is somehow a tool which helps handle the location of a widget inside the widget tree. So you may ask yourselves, well, that means every widget is built within a build context, right? Absolutely correct. In fact, every widget has a build function, a function which gets called whenever the widget is being built in your application. Inside that builder function, you will often see a build context instance passed that lets Flutter know where the widget will sit inside the widget tree. You must know that not all widgets have an user-accessible context by default. For example, a text widget will be built within a context, but that context will be anonymous by default. On the other hand, when you're creating a block provider or whenever you're building a new screen, inside the build function parameters, you will see that there is a build context instance that you can use later on in order to access the context inside your page. To better visualize how build context actually works, we'll watch how the widget tree of our current app is created widget by widget. The app codebase we'll be using is the counter app from my last tutorial regarding block-to-block communication. You can find the source code for that in the video's description. Let's start with the beginning. Every application must start at a point. In Flutter, this point is actually the required main function from inside the main.dart file. The runApp method inside will start building the app, therefore our widget tree. Every tree must always have a root node, a node where everything starts and develops from. Therefore, every widget tree must always have a root widget. In our case, the root widget is actually the first widget created, more specifically, the My App widget. As I previously said, since every Flutter widget is built within a build context, the My App widget will also be built within a build context. Now, please pay a little bit more attention because I'll tell you the relationship between different build contexts. I'm going to tell you 3 completely wrong assumptions you might make during the development of your app. Firstly, you might be tempted to say since all these build context instances have the same name, then that means we're talking of the same build context over and over again. Secondly, you might be tempted to say that since there is no build context instance mentioned as a parameter to a widget, then the widget isn't built within a build context. Last but not least, you might be tempted to think that the context in which the next child widget will be built won't be related at all to the previous context inside the widget tree. All of these assumptions are terribly wrong, and let me explain you why in detail. We'll start with the first wrong assumption. Even though the names of the build context instances are the same here and here and here, this doesn't mean they are identical by any means. This context is completely different from this one, and completely different from this one. This is crucial to understand. Context in this case is just a name for a build context instance, which is passed as an argument to different functions. It's like having 3 different functions, both having the same named arguments, but when called, the passed arguments values will be different, even though the arguments are named the same. In this situation, when there is a build context instance passed to a builder function, you need to start imagining the name context as being the build context in which the current widget is being created. Therefore, in order to make things even more understandable for learning purposes, I'll rename this context the following. The context in which the My App widget is built will be called My App Context. The context in which the block provider of type Internet Cubit widget will be created will be called Internet Cubit Context. And finally, the context in which the block provider of type Counter Cubit widget will be created will be called Counter Cubit Context. I renamed them this way so that you'll see better that they are completely different. When you fully understand this, you'll find it easier to name all of them context, since you'll know which context goes where immediately. Now that we figured out the first wrong assumption, let's move to the second one. As I told you before, every widget inside Flutter has a build function which will require a BuildContext instance in order for it to be built and, most importantly, placed correctly inside the widget tree. So if you're seeing the material app here alone, this doesn't mean it was built without any context. It has an anonymous build context, but it's still a build context like every other widget and will be placed correctly inside the widget tree. Finally, to discuss the last wrong assumption regarding the relationship between build contexts, you need to know that the build context of a widget keeps track only of its direct parent and nothing else. So in our case, our widget built within its next context only knows that its parent is the widget built on the previous context and nothing else. So, to sum up, the relationship between build context is a bottom-up relationship, because the only way to know what's at the top of the tree is to start from a bottom child and work your way up, asking at each step for every parent that is above, until you reach the top. Build context only cares about its parent context. It won't record any information about its child or children. This is crucial to understand because this way you will know that the only way to move inside the widget tree is by choosing a context and then navigating up from there. The only way is up. No left, no right, no down. Just up. This is the only way build contexts navigate between each other. Coming back to our widget tree, every time you see the build function returning a widget, that widget is going to be a child of your current widget. In our case, the My App returns in its build function a multi-block provider. So this widget is going to be built in a new context, this time anonymous. Therefore, the multi-block provider widget will be the child of the My App widget inside the widget tree. Now to continue, we need to understand what multi-block provider really does. Remember from my third Flutter block concepts tutorial when I talked about multi-block provider, I mentioned that this widget was built to facilitate providing multiple blocks or qubits, so that instead of nesting them one inside another, you can create a list and mention them inside it. You need to understand that behind the scenes, multi-block provider will be still nesting each block provider from the list. Multi-block provider is just a way of making the code look more readable and organized. So having this in mind, we can deduce that the block provider of type Internet Cubit is going to be the next widget in our widget tree with its own Internet Cubit context build context. Then, in a new Counter Cubit context build context, another child will be linked to our widget tree, the block provider of type Counter Cubit. Let's continue further. Whenever you see a child parameter, the widget passed will be a child of your current widget. So, Material App goes up next inside the widget tree of our app. Be aware that ThemeData class is not a widget, since it does not extend any type of widget class, so we won't take it into consideration inside our widget tree. In my sixth tutorial from the series regarding block access and navigation, one of the routing options we tackled was the generated routing. So, by default, our application will push in the default home route into the navigation stack, which is linked to our home screen widget. Therefore, the next widget inside our widget tree is going to be the home screen widget. Again, this widget comes with a build method and a new context, which we'll call home screen context for learning purposes. The return widget is the block listener, which will be placed right out the widget tree as we have previously done. Its build context will be called Internet Cubit Listener Context. The block listener also comes with a child parameter, the scaffold, so this will be the next widget inside our widget tree. Now please pay a little bit more attention. As you can see, the scaffold, in our case, receives two widget parameters, the app bar widget inside the app bar parameter and the center widget inside the body parameter. When you see this kind of scenario with multiple parameters filled with different widgets inside the same widget, you need to know that these will be children of the same parent widget. So, in our case, we have two widgets building from the scaffold widget. One will be the app bar child widget and the other one the center child widget. We'll need to see for each of these two widgets which are their children. In the case of the app bar widget, there's only one child, the text widget. On the other hand, the center widget has a column widget child with multiple children. Those will be, again, direct children of the column widget, so they'll be on the same level inside the widget tree. Let's write them one by one. The block builder, the divider, the block consumer, the material button, and again, the other material button. The block builder returns text widgets within a new counter Cubit builder context depending on which state is receiving. Block consumer is almost the same scenario. It will return the counter text widget within similar naming style contexts. Now, please pay more attention to what I'm going to introduce right now inside the material button. You might remember from my tutorial regarding block routing and navigation that we have an onPressed function from where we're calling Navigator.of push, named to push a new screen inside the navigation stack. This is the moment when you will finally encounter why it is crucial to understand how BuildContext works inside Flutter. You might think that this line of code is simply a default way of navigating inside Flutter. Well, it's not like that. Let me translate it to you. Navigator.of context.pushNamed is equal to search for the closest Navigator widget inside the widget tree starting from the past BuildContext instance, and then after the Navigator widget is found, add the new screen widget as a child of the Navigator widget. So let's take this easily, one piece at a time. Search for the closest Navigator widget inside the widget tree. This means Flutter is going to do a lookup after the closest navigation widget, starting from the past BuildContext instance. As you can see, there is a BuildContext instance passed inside of Navigator state. This is done to indicate Flutter from which exact context inside the widget tree the lookup should start. As I told you before, in order to find a specific widget in the widget tree, you'll need to choose a starting context and then proceed upwards, parent by parent, until you find it. So in our case, Flutter will start searching for a Navigator widget right from the provided BuildContext instance, which in our case should be the context of the material button widget. The thing is that since the material button is built within an anonymous context, we can't access it, so we cannot mention it inside the Navigator.of line of code. But can we transform an anonymous context of a widget into a normal accessible one? Yes, we can, and this is done by wrapping the widget inside a builder widget. The builder widget was created to be able to specify a BuildContext instance name in which a widget should be built. So, in our case, all we need to do is wrap the material button inside the builder widget and specify the name of material button context for the BuildContext instance in which the widget should be created. Now, we can pass the material button context to the Navigator.of line of code. For the second scenario, when we'll want to start searching for the Navigator widget from inside the context of the home screen, we'll need to pass the home screen context instance to the Navigator.of line of code. So we'll have two scenarios to test. One starting from the context of material button widget, and the other one starting from the context of the home screen widget. Okay, so let's simulate how Flutter works with both scenarios. In the first scenario, we want to push the second screen onto the navigation stack right after the Navigator widget is found inside the widget tree. We're starting the lookup from the context in which the material button was created, which is the material button context, and then Flutter will ask for the parent widget of it. It will go right to the column widget, then to center, scaffold, and block listener widgets. Finally, Flutter will search inside the home screen context for the Navigator widget. None was found there, so it moves again to the parent widget of the home screen widget, which is the Material App widget. Even though there is no written Navigator widget inside our Material App widget, you need to know that Material App has it inside its core functionality. This is where the Navigator feature starts. So if you are always wondering why the Material App widget contains all the parameters for setting up the preferred routing option, well, now you know why. Because it contains the Navigator widget core, which manages the navigation feature of your app. Okay, so right now, Flutter found the Navigator widget it was looking for. Now it's time for a Navigator to push the second screen onto the stack, but remember, it will push it from the context of the Navigator widget, and that's the context of the Material App. So the new second screen widget will be placed as a child of the Material App widget. So the new widget tree, following our previous rules, will transform into this. Note that if you click the back button, the second screen widget will pop from the navigation stack and will no longer exist inside the widget tree. In the second scenario, the same procedure applies inside Flutter. The only difference being that the lookup starts from the home screen context instead of the material button context, and that instead of building the second screen as a child of the Material App, we'll build the third screen. You need to understand that the translation of the Navigator.of context line of code works also when you're writing BlocProvider.of context, theme.of context, scaffold.of context, or any similar sequences. Therefore, BlocProvider.of context means that we'll search for a specific provided instance of a block or qubit inside the widget tree starting from the provided context. Since there might be multiple provided blocks or qubits, that's why we're mentioning the type of it between angle brackets. I hope you understood how build contexts work and interact with each other overall. If you have ever wondered why wrapping the Material App with block providers causes the blocks or qubits to be provided globally to the entire widget tree, now you know why. It's because all the screen widgets from inside your app will be children of the Material App widget. Therefore, creating and providing them before the context in which the Material App is created, which by the way contains also the Navigator widget, means that whenever a new screen is pushed, searching for the block or qubit unique instance by calling BlocProvider.of context from the context of that screen will go and search for the instance until it finds it above the Material App widget. That's also why if we wrap the home screen widget inside the block provider and then we push a new screen widget, which is going to be a child of the Material App, you won't be able to access the block or qubit instance provided from the home screen inside that new screen widget. Why? Because this is the nature of how build context works. Searching for a qubit or block instance starting from the context of the new screen widget will drive Flutter to the Material App, since that's the parent of the new screen. Then Flutter will go to my app root widget, and since it wasn't able to find any instance of the block or qubit down the road, it will throw the well-known error of BlocProvider.of fails to find a context containing the specific block or qubit. Another thing you need to understand is that you cannot access a block or qubit instance from the same context in which it was provided, so you must ensure BlocProvider.of is called within a child build context. To analyze this theory in more detail, here's 3 examples you need to understand. So, first example. Analyze this code for a bit and let's apply what we learned so far. Can you access the unique instance of block A in this specific case? Pause the video for a moment and think of it. Then come back for the full explanation. Okay, so the answer to this example is yes. You can access the unique instance of block A by using BlocProvider.of block A of context. Now let me explain to you why. The first widget is built in a context build context. Then its child, the block provider, is built in an anonymous context right below it. Bear in mind, whenever you see an underscore passed as a parameter to a function, it translates to, it doesn't matter which parameter it's passed there, we don't care about its name. So in our case, we don't actually care about the name of the context in which block A is created. Then we have a child called myChild, which is also built in a context build context. Remember that even though these build functions have the same parameter names, they're not the same. This is a completely separate context from the context above. We also have a raised button build with its own anonymous context at the end of the widget tree, in which we're asking Flutter to find us the first block provider of type block A. So the context from which we'll start searching is, as you can see, the context of the my child widget. We'll start going up from there, and voila, my app's parent is actually what we were searching for, the block provider of block A, which contains the block A unique instance. Success! Let's move to the second example. Here's the code. Again, I want you to take a look and think whether the unique instance of block A is accessible or not. So, what do you say? If you think the block A is accessible there, you are wrong. And let's investigate why. We have a widget built in a context build context at the top. Then, right below it, a block provider will create the block A into an anonymous context. The raise button will also be built as a child within an anonymous context. We're asking Flutter to find the closest block provider of type block A, starting with the past context. If you pay attention, the past context is actually the one in which the top widget was built, since the other created widgets have anonymous context which we cannot access. So, in this case, Flutter won't be able to find the block provider of type block A, therefore, throwing the well-known error of BlocProvider.of fails to find a block or Cubit. So, do you think there is a way on how we could adapt this specific example in order to make it work? The widget tree looks rather good if we only had an accessible context in order to start a lookup from there. We can now start a lookup from this context, and since the block provider is actually above this context, we know for sure that the unique instance of the block A is accessible. This was example number 3, and I hope you understood why knowing how build context works is crucial. We're almost at the end of this important tutorial. What's left for now is for me to tell you a trick on how you can easily visualize the widget tree of your app without having to manually write it down every time. So, first of all, inside VS Code, you'll need to build and run your application, then hit Ctrl-Shift-P and search for Dart DevTools, then open it in a new browser tab. If you go to Flutter Inspector, you can notice the entire widget tree which is currently built inside your app. As you can see, it's actually the same widget tree we manually built. How convenient! So whenever you have doubts in which context a specific widget is built, you can now double check it inside Flutter Inspector. This was definitely a long but really important tutorial. Build context is actually one of the key concepts of Flutter, so understanding how it works underneath will win you big time in the long run. If you like this tutorial, make sure you hit the like button, share it to all your colleagues and friends, and subscribe to my channel. A comment of appreciation or feedback will help me a lot. Also, make sure you leave a comment for whatever question or request you might have. Thank you for watching. Until next time, stay safe. This was Wicked. Bye bye.